Welcome back to the channel. In today's video, we are diving into LeetCode problem 3014 by the name of minimum number of pushes to type word. A really fun and smart problem that tests how well you can optimize typing on a classic mobile keyboard. Imagine you're typing a word on an old school phone where every key has multiple letters and you need to minimize the total number of button pushes. Sounds simple, right? Not exactly. You have to think strategically which characters should go on which keys and how do you assign them to reduce the overall cost. In this video, I will break down the logic step by step, explain the optimal strategy, and walk through the solution in a clear and beginner-friendly way. Whether you are preparing for coding interviews or leveling up your code problem-solving skills, this explanation will help you understand the concept deeply. So stay tuned, hit the like button, and let's jump right into the solving this problem. So guys, let's start to solve our question number 3014 by the minimum number of pushes to type word 1. So this is an easy one question which we are solving in today's video. And this question is included two hints also, but we weren't view these two hints, and there are the total four topics are included: math, string, gradient, weekly contest, creative one. So first of all, we understand the question, what is the question trying to say, and we'll be start to solve it in the LeetCode website. It is giving me a string word containing distinct lowercase English letters. Okay. Telephone keypads have keys mapped with distinct collections of lowercase English letters, which can be used to form words by pushing them. For example, the key 2 is mapped with A, B, C. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys numbered to 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to the string word. We want to run the minimum number of pushes needed to type word after remapping the keys. An example mapping of letters to keys on a telephone keypad is given below. Note that 1 star hash and 0 do not map to any letters. Okay, and there are the diagram here. You can see it in one there is not anything, in 2 there is ABC, in 3 there is DEF, in 4 GHI, and 5 GKL, and in 6 MNO, and then 7 PQRS, then in 8 TUV, in 9 WXYZ, and then there's a star, 0, and hash. Okay, and let me tell you highlight some things which I am telling you. Highlight this not word, highlight this minimum word. Okay, it will be help you. Exactly word, highlight that, highlight this minimum, highlight this must, and then highlight this any. Okay, highlight this string. Okay, and then highlight this also, and then highlight this upper word also. That's it. Okay, now let's come down. Example 1. Here's example 1. If you see, here's a first diagram in example 1. This is the same example as you seen above. Okay, like 1 then 2 AFLG. No, it is different. How? Because the alphabetically is wrong. If you see 1, then in the 2 AFG, okay, and in 3 BHI, then in 4 CJK, and then in 5 DLM, then 6 ENO, then in 7 PQRS, and then 8 on 8 TUV, and in 9 WXYZ. Okay, if you see the input here, you get a string by the name of word, in which he wrote in on A, B, C, D, E, and the output I'm coming 5. Why? because the remapped key given the in an image provides the minimum cost, like A, one push on key 2, in B, one push on key 3 if you see the diagram, and in C, one push on key 4, okay, and then in D, one push key on key 5, okay, and then E, one push on key 6, okay. So like this, and then total cost 1 plus 1 plus 1 plus 1 plus 1 plus is equals to 5. So it can be shown that no other mapping can provide a lower cost, okay, like A pushes to this, and then B pushes to 3, and then C pushes to 4, and then D pushes to 5, and then 6 pushes to uh, E. Like if you see here, A, here's A pushes to 2. Let me give him only outline. Here you can see A pushes to 2, A pushes to 2, and then 3, B pushes to 3, and then C pushes to 4, and if you see here, 5 pushes to D pushes to 5, and 6 here E, like A B C D E, okay, like this it is, okay. So that's why the upper ending coming like 5, because 1 plus 1 plus 1 plus 1 plus is equals to 5. Example 2. If you view the example 2, in which there are the alphabetically is totally different. There is in number 2 XY, then in number 3 CD, in number 4 EAB, in number 5 FKLMN, and in number 6 GOPQ, and number 7 HRSTU, and in number 8 IVWZ, in 9 in the number 9 there is a G, and then star, then hash. And if you see the here you get a string by the word in which he wrote in an X, Y, C, D, E, F, G, H, I, J. So the upper end coming 12. Why? Because the remapped keypad given in the image provides the minimum cost, like X, one push on key 2, Y, two push on key 2, C, one push on key 3, D, two pushes on key 3, and then E, one push on key 4, F, one push on key 5, then G, one push key on key 6, and then on H, or one push key on key 7, and I, one push on key 8, and J, one push on key 9. And the total cost is 1 plus 2 plus 1 plus 2 plus 1 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 plus equals to 12. So it can be shown that no other mapping can provide a lower cost, okay. If you see here, x and sorry, here we want to paste it. If you see here, x and y, so there are the two, okay, it is 2 x y, okay. X y, then there is when xy, then c d e, then there is coming c d, here you can see it, and then there is coming e, and then f, and I, here you can see it, C D E F, sorry, G, then there is coming G, and then H, here you can see it, there is H is coming, then I, then J, here you can see in the end. So it is looking like this, okay. A, B, C, D, E, and then F, then G, and then H, then I, then J, okay, like this, simple. So there are the three constraints that also be included in today's question, but we do not see any constraints. So it is working like this, okay. I understand this question, so easily I will be solve it, okay. And it is also easy one question, okay. So let's try to solve it in Python 3. So first of all, what we're gonna do now, we define a class of a solution, def minimum pushes self comma word. What is our str? So minus greater than int. Here we define int equals to 0 and equals to length. We found the length of our word. Row equals to 1. Enter enter. We define quotient equals to n divided by 8. Remainder equals to n 8. Okay. Enter enter. We define whole while quotient equals to greater than 0. Enter. Sorry, do not press many enters, okay, it causes an error. Ans plus equals to 8 multiplied by row quotient minus equals to 1 row plus equals to 1 ans plus equals to remainder multiply by row, and then we return we return our answer. So let's do the running code. So when I run this code, so now the running code has been accepted or not. Let's check it out. So it is giving me an error in running. So let's see what is our error in this code. So let's come on it here. Here we define 8 and then 0. Let's run it now. So it has been accepted. Okay, we want to write 0, but by mistake I write 8, so that's why it is giving me an error. So in case when the expected output false, the output incoming same. In the case you expected output 12 and output incoming same. So let's see the submission code. So when you submit this code, now the submission code is accepted or not. So let's check it out. So it has been accepted and I beat total 100% people easily. So if you enjoyed this video, so don't forget to like, share and subscribe. So or more amazing D-Stab or LeetCode camp solving solutions. If you want to I'll solve more questions in one day. So tell me in the comment section below. So now let's meet in the next video, and next video amazing video like this. And you can also review my LeetCode camp profile, it is amazing. Okay, now here you can see it, so please go and check it out. And if you do not go onto my channel, so come onto my channel by the name of Rayyan, and please first of all like, share and subscribe and press the notification bell and see my all the videos of LeetCode camp. And here you can see it, these are all the videos, and come on to the playlist, come on to the LeetCode camp playlist, and please access my playlist and bookmark it also. It is very helpful for you, okay, for you, and you will be job ready in Google, for Microsoft. Means that you will be job ready totally on based on FANG jobs, okay, FANG jobs. So please go and access this place and bookmark it also. So let's meet you in the next video amazing video like this. So for today, goodbye.